Hey guys, welcome back for another lesson. Today we're working, if you have these notes, hopefully in front of you or somewhere where you can see them, really so that you can see them or go back to them. If there's something you can't read on Edpuzzle and you're using Edpuzzle only, then you need to pause your Edpuzzle and go back and just look at the notes instead of looking at Edpuzzle because I can't do all of these edits and everything for you guys that aren't taking the time to do that. So you need to do that for yourself. Okay, so we are looking at angle relationships that happen inside the circle. So these are different angle relationships. And the first one, this is a separate theorem, but the way I want you to think about this is the same way that you would think about an inscribed angle. Our last lesson was all about inscribed angles, and we graded that homework yesterday. And so this should seem relatively easy for you. When you look at number one, you have to remember an inscribed angle has its vertex on the circle. So what's actually happening here is this is a tangent line to a chord, right? A tangent line to a chord, and it's creating an inscribed angle, and it intercepts an arc. So it's still the same relationship that we saw the other day. This arc is 234 degrees, which means that this inscribed angle would be 117 degrees, all right? And then you have the angle, which is supplementary, right? These two angles are supplementary to each other, which means the measure of angle one would be 63 degrees here. And if you wanted to, you could go ahead and double the 163, and that would be the rest of this arc would be 126 degrees. And you can see 126 plus the 234 make the full 360 for the circle. So there's a lot of good relationships going on here. And if you just think about these as inscribed angles, it should seem simple. So I'm going to let you go ahead and find the measure of angle 1 for number 2. All right. This one should have been a little bit easier. All you had to do is take the arc that angle 1 is intercepting, 172, and divide it by 2, giving you 86 degrees on that one. All right, number 3. Try out number 3, please. Okay, so for number 3, I got 116. How did you do? When I looked at number 3, there's actually 2 different ways that you can do this, and it doesn't matter which way you do it. I'm going to go the opposite way that I did number 1, so you can see a different way to do it. If I have 128 here, I can do 360 degrees minus 128 degrees. Oops, I didn't need to do that, did I? Oh, this is wire. So I have 2, 5 minus 2 is 3. Sorry, this is going to be 3 minus 1 is 232. So the rest of the circle, this arc over here, has a degree measure of 232. And then to get angle 1, we're just going to divide that in half, which is 116 degrees. That would be your final answer. All right, so the theorem that goes along with this is actually right here at the bottom. If you have your theorem paper with you, go ahead and you can write this in there. But this is if a tangent and a chord intersect at a point on the circle. So that's what we're talking about before. We have a tangent and a chord, and they're intersecting on the circle. The vertex is on the circle. Then the measure of each angle is half the measure of its intercepted arc, and that describes an inscribed angle. So there you go. All right, so we have 2 more theorems to look at, and we have chords. The first one is chords that intersect inside the circle. Inside the circle follows this theorem. If 2 chords intersect inside a circle, then the measure of each angle is half the sum of the measure of its intercepted arcs. So we're going to basically add up the arcs and then divide it in half. So since there's 2 arcs, we'll be getting an average, basically. So if we wanted to find, looking at just the diagram, if we wanted to find the measure of angle 1, to find the measure of angle 1, we could do its intercepted arc here, DC, and the arc of its vertical angle, right? This is its vertical angle to angle 1. We're going to add those two arcs together and divide by 2. So it'd be the measure of arc DC plus the measure of arc AB and just divide it by 2. And that's the formula basically that you use for these kinds. Now you could do the same thing for number 2, but what you should recognize is that 1 plus 2 have what kind of relationship? Yeah, they're supplementary, or they add up to 180 degrees. So I mean, to find angle 2, you could just take angle 1 and subtract it from 180 to get your angle 2. Or you could do the same thing to find angle 2. You would be looking at a different set of arcs. We could do arc AD, the measure of arc AD, right? That would be its vertical angle plus its intercepted arc itself, the measure of arc BC, and then add them up and divide by 2. So that's the simple formula. I'm going to let you go ahead and try that out on number 5. All right, so for number 5, you should have gotten 82 degrees. And let's take a look at how that comes into play here. So we're going to look at, here's angle 1, here's one arc that's intercepted, it's 131 degrees. Here's the other one at 33. So to find the measure of angle 1, we're going to add the arcs and divide by 2. So we get 164 divided by 2, which equals 82 degrees. All right, number 6 is a little bit different. It's a little bit variety of that one, but it's still the same formula. So take a moment to find the measure of angle 1 for number 6. All right, did you get 74 degrees? Hopefully you have 74 degrees. What I'm going to do is go ahead and find its supplement, and I'm just going to call this X right here. And it doesn't matter which side, right? Because both of these are vertical angles, so both the same, excuse me. So if I want to do the measure of angle X, I'm going to add these intercepted arcs, 115 plus 97, and divide by 2. So let's see, that is going to give me 115 plus 97. The measure of angle X is going to be 212 divided by 2, which gives me 106 degrees. So this is 106, and these are supplementary to one another. So I'm going to do 180 minus 106, which will leave us with 74 for the measure of angle 1. All right, last one before we move into our last theorem. Go ahead, number 7, find your value of X. Same formula. Did you get 125? All right, so for this one, we have the angle. So I'm going to say for this one that 115 degrees equals 105 plus X divided by 2. So you're simply going to solve for X. Multiply by 2 on both sides. So 115 times 2 is 230. And then just subtract the 105 from both sides, and that's where you get the 125 from. All righty. Good job. Next page, we have our last theorem to look at. And this theorem has to do with an angle on the outside. Now, some of these things we haven't talked about yet. You should recognize your tangents, right? Like here, we can see this tangent line, to point C. And in the second demonstration, we have two tangents. But what about these other lines? We haven't talked about these other lines. The other lines, they go through the circle at 2 points. They're like a chord that's been lengthened, right? So instead of a segment that's a chord, it's like a line now, and it's called a secant. So it's just like the taller brother of the chord. It's called a secant. So here we have a secant and a tangent. Number two, we have the two tangents. And number three, we have two secants. The only difference is that the theorem's a little bit different, but the intercepted arcs are a little different. So we're going to highlight those and write out the theorem for all of these so you can get the idea. But the theorem goes through each of the three ways that this can happen. If a tangent and a secant, two tangents, or a secant, or two secants, intersect in the exterior of a circle, right? All these angles and all these lines are coming together outside the circle. Then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So this time we are going to subtract. We're going to subtract. So here's what we're looking at. These two lines intercept arcs. There's always a small arc. The smaller arc is closer to the angle, and then the larger arc is further away. So to find the measure of angle 1, we're going to do the bigger arc, which is always further away. So the measure of arc BC minus the smaller arc, the measure of arc AC, and then we're going to divide that by 2. We're going to take half. All right, that's what it looks like when you have a tangent and a secant. Here, this is an interesting problem, and this problem with the two tangents is going to bring you some extra challenges, and we'll do one of those today together. But you're going to notice that the bigger arc, PQR, together with the smaller arc, take up the entire 360 degrees, and that's going to help you out with some of your problems. But it's still the same relationship. So to find the measure of angle 2, we're going to do that big arc, the measure of PQR, and we're going to subtract it from the smaller arc, PR, and then divide by 2. All right, and the last one, happy purple, here we go. Angle 3, we have a large arc here that is XY in the back, and a smaller arc up front, which is WZ. So those are the two arcs that you're going to subtract to get angle 3. So the measure of angle 3 is going to be the measure of arc XY minus the measure of arc WZ divided by 2. All right, so these are the three different scenarios, but really when you see the angle on the outside, you're going to do the difference. You're going to do the difference and then divide by 2. So it's really not that bad. I'm going to let you go ahead and do number 8 because number 8 is straightforward. It's nice. All right, did you get 24.5? I got 24.5. So to find the measure of angle 1, here's our arcs. We have the 92 degrees and the 43 degrees. So to find the measure of angle 1, we're going to do 92 minus 43, and then we're going to divide it by 2. So 92 minus the 43 gives us a 49. And then 49 divided by 2, that's the 24.5 degrees for the measure of angle 1. All right, number 9. Let's look at number 9 for a second. So we have arc that's 134, but we don't have this piece back here. Can you tell me the piece, or the measurement of that missing arc length? Okay, hopefully you said 214 degrees. 214 degrees is this missing piece, and let's see how we get that. We have so far, and you notice this is a tangent, right? So this is a point. This arc goes up to that point to here, and we have 112. So with the 134 plus the 12 degrees, we have 146 degrees used in our circle. The rest of the arc measurement is going to come from the rest of the circle. So we could do 360 minus 146, and we get 214 degrees. So that's this piece that's over here. All right, so using that whole circle is going to help you find some missing arc measures. And then it should be nice and easy to find the measurement of angle 1. We're going to say 214 degrees minus 134 divided by 2. So the 214 degrees minus the 34 is 80. And 80 divided by 2 is 40 degrees for angle 1. Okay, you ready for a challenge? I'm going to ask you to stop for a moment, take this all in, and see if you can get the answer. Okay, anybody come up with 220 degrees for arc ABC? So I asked you to find this back one. If you said 140, that means you got the smaller one up front. So if you didn't get that, I'm going to kind of walk you through this a little bit. The only thing they tell us here is that the measurement of angle 2 is 40 degrees. Now, just because this answer is the same as number 9, it's a different setup. The arc measures are different. So don't just go think that you can grab the answers from number 9. It's not going to work that way. What you have to do is realize that this is two tangents, and the arcs add up to 360 degrees. So you're going to use algebra to help you do this problem. I'm going to go ahead and call arc AC x. This is going to be x degrees. What would be the algebraic expression that I use for arc ABC? Well, you should be saying that I'm going to do the whole entire circle minus this piece. So this arc is going to be 360 degrees minus x. Yep, good old algebra coming back into play to help us out. So to find the measure of the 40 degrees, right, angle 2, we're going to do the bigger arc, 360 degrees minus x, and we're going to subtract the smaller arc from it, and then divide by 2. All right, go ahead and take a moment, see if you can finish that up and get the correct answer. All right, so I'm multiplying by 2 on both sides. 2 times 40 is 80, right? And don't miss this. This is a negative x and a negative x, so it's 360 minus 2x. So the first thing I'm going to do is I'm going to subtract 360. Now I'm going to get a negative 280 over here, and we would usually panic a little, but that's okay because this is a negative 2x. So when I divide by the negative 2, I'm going to get 140 degrees. Now the 140 is my x value. So here I'm going to do 360 minus the 140, and that's where my final answer of 220 degrees comes from. Okay. Thank you so much for joining me. Hope you learned a lot. Hope the homework goes well. God bless. Bye-bye.